Dear students, welcome to online gate class. First of all, I have to thank Mr. Ashok Kumar sir and my dear friend Anand Kumar. Actually, many students have studied in this institute. Actually, this institute is called as Sri Krishna Institute, located in Chennai. Um, Mr. Ashok Kumar sir is one of the dedicated teacher. He produced many good students to the society, and Anand Kumar was one of the student of Mr. Ashok Kumar sir. Is well known to me. This entire material is prepared by Mr. Anand Kumar. I think many students have uh, a material, gate material, which prepared by Mr. Anand Kumar. So with immense pleasure, I thank Ashok Kumar sir and Anand Kumar for their valuable effort taken towards the betterment of students. Yes. So from this figure, you can get how to compute the RL of but reduced level of particular point. Okay. See, actually this line is a mean sea level. This is considered as mean sea level. Before partition of India, initially Karachi was taken as a benchmark during the British government. Karachi was taken as a standard benchmark. After the partition of India, Mumbai. Actually, currently it is called as Mumbai. Previously Bombay. So Bombay was considered as a mean sea level. Okay. So let us consider a benchmark. It has known RL with respect to mean sea level, which is taken at Bombay. That is Mumbai. Okay, so RL of benchmark is known with respect to mean sea level. This benchmark is provided throughout the India. Okay, in the national wise, that benchmark is fixed by Central Public Works Department. Then the state wise benchmark is fixed by the state level public works department. Then we can go for temporary benchmarks, arbitrary benchmarks. So this can be fixed by the construction people. Okay, so this is the benchmark. Okay, first here the first setup of instrument is taken is considered here. So this is the instrument. The instrument is placed here. So by keeping the leveling stock, keeping the leveling stock over the benchmark, you can get y1. Okay, y1. So this is a back side. We know that the first reading for every setup of the instrument is known as back side. Okay, then so this is y1. The first reading is taken on benchmark. It is not compulsory, it is not a condition to take the reading, first reading on benchmark. We can take anywhere, but the first reading is considered as backside. Okay, next y2. So next that leveling stuff is moved to this place, and this is y2. Okay, next again the leveling stuff is moved somewhere. Okay, this is a y3 and y4. Okay, so look here, y1, y2, y3, y4. So after that, after this point, the instrument will be changed. Okay, instrument will be changed. Look, okay. Actually, I'm very sorry. Actually, in the previous class, I mentioned that change point means not instrumentation. Change. This is a change point. So change point means it has two values, backside as well as foresight. Okay. See here next. So after that, this instrument to be shifted here. Okay, but do not change the leveling position of leveling stuff. Okay, so again the last reading of instrument station for this place is considered as foresight. See here, foresight. Okay. After that, the instrument to be changed to here the corresponding value, the corresponding first reading is taken as backside. Okay, and last one is in foresight. Intermediate values are considered as intermediate sides. Okay, so now what is how to find RL of this place? So we have to find what is RL here, what is the RL here with respect to mean sea level. With respect to mean sea level, what is the RL of this point and what is the RL of this point? What is the RL of this point? Okay, yes, please come. Already we know the value of benchmark. So benchmark, this is a fixed benchmark, permanent benchmark. It has known RL. Known RL means known reduced level with respect to mean sea level. Say 100. The RL of benchmark is 100. Next, y1 is already got it. Okay, with the help of dumpy level, we got this y1 value. Say 0.385 meter, 0.385. Okay, if you add 100 plus y1 value, you can get the RL of line of sight. RL of line of sight. So it can also it is called as height of collimation. So what is the height of collimation? RL, see here, RL of benchmark plus backside reading. So backside reading. Okay. So now you can get RL of line of sight or RL of height of collimation. Sorry. This RL of line of sight never changed. It never changed. Okay, even though n number of readings are taken for a particular instrument station, the RL of line of sight is constant. Is same for all the readings. Okay, so now you have RL of line of sight, then minus y2 you can get RL of this place. Okay, RL of this place. So RL of this place equal to RL of height of the collimation minus y2, it gives RL of this place. So that value nothing but RL of this place with respect to mean sea level. Similarly, you can come to here. Now we have here, what is this? RL of line of sight or RL of height of collimation minus y3, you can get RL of this place. Okay, and come to here. So this is a change point. This is a change point. Okay. So in order to get RL of this point, so RL of line of sight, RL of this line of sight minus y4, you can get RL of this place. Okay. Next the instrument to be changed here. So that is so this is a general procedure. Do not change the position of the leveling staff for the change point. Okay, because for which we have to take two readings. One is foresight and another one is backside. So after changing the instrument here, take the first focus the last reading, last position. Okay, last position of last reading, and the corresponding value considered as backside. Okay, what is RL of this point? How do you get the RL of this point? So already we know RL of this point, RL of this leveling station. So RL of this point plus B5 backside. So RL of change point, change point nothing but this is change point. So reduced level of change point and backside it gives the RL of this height of collimation. Okay, height of collimation nothing but line of sight. Next, RL of reduced level of line of sight minus y6, you can get reduced level of this leveling station. So finally, similarly, you can get RL of this place. So this is a way to consider the RL of point. Suppose in some cases leveling staff was held inverted. Okay, so those situations we have to apply some concepts. Next, see, actually, this picture was not given in the examination. Okay, actually, read carefully. First, the reading is 0.9 meter, 0.8 meter, 1.2 meter, 1 meter, 0.8 meter, 3 meter, 3.2 meter. Generally, height of the benchmark will be, the height of leveling staff will be 3 meter, 4 meter, 5 meter. Look here. So after 3 meter, there is no reading. Hence, we can say they used 3 meter leveling staff. Okay. First reading point 9, next point 8, next one, see here, point 9 value decreases point 8 and suddenly again 1.2, 1 meter, point 8, again increases 3 meter and 2.2. So first initially decreases, again increases, decreases. It means that the gradient will be uh, normal. It is not normal gradient. Okay, there is steep gradient. Okay, see here, first so gentle, we can assume first reading may be back side. Okay, after that 0.8, after that 1.2. So if it is, if value continues as, we can consider the 0.8 may be considered as intermediate, but after that again it starts 1.2. So definitely it is a steep gradient. The land will be a gradient land, not even land. Okay, so consider this is maybe back side, foreside, and 1.2, 1 meter, 0.8. So continuously decreases 1.2. Okay, so it is a back side. 1 meter we don't know idea. 0.8, okay, no idea. Again 3 meter. So definitely this will be foresight. It may be a last point for a particular instrument. Okay, for a position of particular instrument, and this is 1 meter, intermediate sides. Okay, again 3 meter back side, 2.5 meter foresight. So this is a way to fix the way to determine the position of, or the nature of the gradient. See y1. So y1 is the backside and benchmark. Y1 is considered as a over the benchmark, maybe okay, first reading backside. If y3 less than y2, y3 is less than y2, it will be considered as intermediate. But this is not the exact one. So with a logical approach only we can do it. Okay. Next, please come to here. See here, this is roof level of residential building, roof level. Okay. Then how to get the RL of this place, RL of this roof. So with respect to benchmark, place this instrument position and benchmark, place the leveling stop over the benchmark, and this corresponding reading, the first value is considered as backside, say y1. Now we can get the RL of this place, RL of this line of sight, benchmark plus and backside gives the RL of height of collimation. Then here leveling stop was held inverted. Okay, in during the observation it is considered as negative. It was noted with negative value. Okay, so how do you get RL of this point? So benchmark is here. RL of benchmark is say 200 plus 1 meter, 200 plus 1 201. So RL of height of collimation, RL of line of sight is 201 meter. Say this is 2 meter. Okay, this is, say it can be observed because this is held in inverted position. So 0 here. In the leveling staff, it is leveling staff was held inverted. It means that 0 here, 0 touches the roof of the slab, and here this is the 3 meter. Okay, say this is, so let us consider this is 2 meter. So RL of line of sight plus 2 meter gives the RL of roof level. So this is the way actually in they will y2 will be considered minus, so minus or minus plus. Okay, but no need to mug up any formulas. Just apply the concepts. You can get ideas. Okay. Next, here read the captain of ship having elevation of his eye 6 meter above the sea surface just sees the top of the lighthouse having a height of 40 meter and above the sea surface. Determine the distance between the ship and the lighthouse. Say actually, so from the ship, a captain is looking a lighthouse at a distance. Okay, that height of the tower is 40 meter. Height of the eye level, captain eye level with respect to mean sea level is 6 meter. So we know that formula, combined error formula. Say let us say this is D1 and this is D2. Okay, so use the combined error formula. Okay, combined error is always positive. D1 is, this is D1. Similarly, you can find D2. Okay, you can by using the same formula, because after finding D1, okay, after binding D1 and D2, you can find the final distance. Okay, because this is a combined error. Okay, curvature error, effect of curvature and effect of refraction. By using these concepts, You can find the distance from human this to this. This is your normal position. Okay, so D1 and D2. For all, probably you can use the same concepts. Okay.